Well, hello, scholars. Today, our focus is going to be on really looking at different counting examples and being able to distinguish between when a permutation counting method is correct and when the problem is asking for a combination counting technique. Now, remember that from these two, that really the permutation counting technique is really for an arrangement. We're using the items non-repeating, and we're going to look for things like arrangement. We might be looking for things like something that's lined up, or maybe some sort of race finish, or where different positions on a team are specific, or even where the problem asks for a sequence. A combination, on the other hand, is really where the order doesn't matter, and it's really focused on looking at a group, and where that group is not really distinguishable for each one. So we're going to be looking for things like a selection, or maybe a team, or a group, or some sort of choosing where again it doesn't matter the order that it's chosen. So we're going to look at a few examples, and then you'll be able to practice this throughout the assignment. So the first example is how many ways can 4 candy bars be chosen from a store that sells 30? And so again, the key item here is the word chosen, and chosen would think that again that would lean towards combination. And so if we're thinking of a combination, then we want to think, okay, well, we have a total of 30 candy bars, and so from that we're going to choose 4 of them again, and then using your calculator shortcut, you'll see that we'll have 27,405. Now, in the next one, we wonder how many ways can 13 students line up for lunch. Again, everyone's going to go to lunch here, so the key phrase we're looking for, or that we can see, is line up. Means that the order matters, right? It matters whether you're first or last when it goes through the lunch line. Maybe not, hopefully, but the idea here is that this is going to be a permutation, right? And so a permutation, again, when we think of, we're going to count all of those, and all 13 get ordered. This is also 13 factorial. Remember that shortcut with that. And so we'll see that this is actually quite a large number. We're talking about 6,227,000,000. If we look at the third example here, how many ways can you arrange a 3-letter arrangement with the word trapezoid? The one thing we want to pay attention to is to watch out for any duplicate letters that might be when you put words together. If you have a duplicate letter, they're not going to actually be a different arrangement, or it's not going to look like a different arrangement. So this is a permutation. And in this case, the word trapezoid does not have any duplicates. So we can really just think of, okay, we've got 9 letters to choose from, and we're choosing 3. And so we end up with 504 ways to do that. Here are some other examples where we have to choose between the 2 counting techniques. Again, 7 students working together on a project. The teacher needs to choose 4 people to present perhaps that day. And so again, the word choose would tell us that it doesn't really matter who gets picked, what order they get picked. They're not talking about the order that they're going to go. And so this is a combination. And out of the 7, we would think that there's not too many ways. We would think that there's again, it turns out to be 35 different ways that 4 people can be picked for that particular day. The next question has to do with some offensive hockey players on a team. The coach wants to choose specifically some positions: the left wing, the center, and the right wing. So because those positions are specific, you play the left side, the right side, whatever, this is going to be a permutation. Now, out of the 18 players, we can see that there's going to be quite a few ways that we can have for those. So we end up with 4,000 and and 896. Now, in the last one that we'll look at, there's different 12-letter arrangements for the word from the word Indianapolis, and Indianapolis has 12 letters, so we're going to arrange all of them in order. However, we want to pay attention to duplicates here, so we do have a permutation. However, we need to look and say, okay, well, we have the letter I actually occurs 3 times. The letter N occurs 2, and the letter A occurs twice as well. So what we have to do is, remember, we have to divide out the different arrangements that those letters will happen within the word itself. And so easy way to do that is just to take all 12 letters and take the permutation and then divide out the 3 factorial for the letter I that is done 3 times, and then 2 factorial for each letter N and letter A. And so when you divide those out, you're reducing the amount of arrangements that are there, and this turns out to be about 19 million ways that you can do that. So again, use your shortcut on the calculator. Remember, that's in the math menu underneath probability for NPR and NCR.